So IDeATe stands for the Integrative Design Arts and Technology Network. We have 10 minors, everything from game design and animation to physical computing, our XR, virtual reality minor. A lot of different areas, heavy need for fabrication in all of them really. Like we teach education, we teach design, but our focus is on iterative design. You have an idea, you make a prototype, you test that, you refine it, you retest it, and you keep going. And so naturally 3D printing fits into that workflow. My name is Cody Soska. My role is the technical specialist for the Integrative Design Arts and Technology program, and I oversee our day-to-day operations, all of our equipment usage. I train students and prepare faculty to use the equipment in their curriculum. 3D printing is a huge part of my job. The biggest demand and constraint on our 3D printing was throughput and reliability. We needed to crank out nothing particularly complex, nothing mechanically intensive, nothing with incredibly high detail. We just needed to have lots of parts ready when the students needed them to be ready. They need to have something to bring to the next class in 2 days. They have to design, submit, and print something with a 2-day turnaround. That's not possible unless you have reliable 3D printing. The cost model on Array is fantastic. I'm buying material from Mosaic directly at a cost that rivals generic material. And I know I'm getting the best stuff from the company that's just going to work in my printer. Array is different from 4 3D printers because it has continuous print capability, it has large print capability, and it has multiple ×8 filament capabilities. The gantry and end effector system is a reliable, beautiful way to just continuously print. It's fantastic for this. Clearly spec'd higher than it needed to be, I'll be honest. I mean, there is some hardware on there, high wind steel. There's a ball screw on here I can't stop looking at. It's incredibly robust. Well, the gantry system from Array unlocks the ability for me to go home on time. Let's start there. I mean, because seriously, like I send a bunch of parts to print, I don't have to wonder if they're actually printing. I don't even have to leave my office to do that. I'll just pop on a camera on Canvas EDU and see that it's printing. I can see a bed is there. If I walk into this print room and without even walking up to the machine, I can see 4 prints running successfully on all 4 printers. I see a bunch of completed parts. I know it's just doing its job. It's just there and it is doing the most tedious part of my job for me. Canvas EDU has really empowered our students to be stewards of their own print process. They design the file, they submit it, they select the options, and they're sending me a sliced profile of a part for approval. They can submit their own parts, they can set their own parameters, and I can communicate with them directly and just say, hey, change this one thing, you're good to go, or you'll need to make the following changes. It's all right there for you, go ahead and do it. With other print manufacturers, they just didn't have these tools available for students, so I would have to do something on the back end that is a mystery to students, and they should really know what I'm doing and why. Students at all levels of education should have access to a system like Array. It is essential that if we're going to be encouraging STEM education, we're going to be encouraging design, engineering thinking, prototyping, iteration, that students have a reliable 3D printer that will make their parts in the volume they need. Array is going to change the face of STEM education. 10 years ago, having a 3D printer in a classroom was a big deal. But you can have, and this is real with the price point, an elementary school could easily buy one of these machines. 10-year-olds can get an experience that anything you can think of, you can make, and it will look like the item in your mind. That's just so valuable. And at a collegiate level, well, if the number of iterations on a design leads to a better design, then we have now increased our iterative capacity by an order of magnitude.